Good day viewers, you're welcome back to my channel today. Please, if you have not subscribed to this channel, please subscribe and turn on the notification bell so that you'll be notified anytime we upload new video. Today we're holding a tutorial on how to prove the demoivre's theorem. Okay, now let's get started. If x is equal to cos theta plus I sine theta, okay, plus I sine theta, then x raised to n is the same as cos theta plus I sine theta raised to n. Then according to his theorem, so we have x raised to n to be equal to cos of n theta plus I sine n theta. Okay, now x raised to the power negative n will be equal to cos theta plus I sine theta close bracket raised to power negative n, and from here this is equal to cos of negative n theta plus I sine of negative n theta. Okay, now recall that the cosine function is an even function, so cos of negative n theta is the same as cos of n theta, then plus the sine function is an odd function. Okay, so sine of negative n theta will be what? Minus I sine of n theta. Okay, now from here we have the following, that x raised to n is equal to cos n theta plus I sine n theta, and x raised to negative n, which is the same as 1 all over x raised to n, is equal to cos n theta minus I sine n theta. Okay, now we're going to derive his famous formula. And how do we do this? Okay, now let's subtract the two equations. So let's say this is equation 1 and this is equation 2. Okay, now subtracting both equations, so we have x raised to n minus 1 all over x raised to n minus 1 all over x raised to n to be equal to cos n theta plus I sine n theta minus, in bracket, minus cos n theta minus I sine n theta close bracket. Okay, now simplifying this, so we have here cos n theta minus cos n theta is 0. Okay, now we have I sine n theta minus, now here we're having negative sign to open up this bracket, so this sign is going to change to a positive sign, so we have I sine n theta plus I sine n theta, and that is equal to 2I sine n theta. Okay, so this is the first theorem of this demoivre, and we have proven it. So we have that x raised to n minus 1 all over x raised to n is equal to 2I sine n theta. Okay, now we're going to prove the one of addition. Okay, so now from here from where we stop now, so we have x raised to n. So when adding both equations, so we have x raised to n plus 1 all over x raised to n plus 1 all over x raised to n to be equal to cos n theta plus I sine theta. So we have cos n theta plus I sine n theta, close bracket, okay, plus in bracket cos n theta minus I sine n theta. Okay, now we'll continue on the other page. So now we continue on the other page. So we have now x raised by n plus 1 over x raised by n to be equal to, here we have cos n theta plus cos n theta, so we have cos 2 cos n theta, okay, and here we have I sine n theta minus I sine n theta, and that is equal to 0. So we have now that x raised by n minus 1 over x raised by n is equal to 2I sine n theta, and again x raised by n plus 1 over x raised by n is equal to 2 cos n theta. Okay, now we're going to solve one problem using this theorem. Okay, and what is the problem? So let's take a look at the problem. So we have problem: if x plus 1 over x is equal to 3, then x raised by 3 plus 1 over x raised by 3 is equal to that. We're going to use this theorem here. Okay, let's see how we're going to solve this problem using this theorem. It is good to know how to apply a theorem than just to know how to prove it without the application. Okay, now we have x plus 1 over s equals 3. So we're going to make use of this formula with a positive between these two expressions here. Okay, so we have x raised by n plus 1 over x raised by n to be equal to 2, so is equal to 2 cos n theta. Okay, now remember that in this equation x plus 1 over s equals 3. The power of x here is 1 and here is 1. So in this case we're going to substitute n as 1. Okay, so if you take n equal to 1, so we have x plus 1 over x is equal to 2 cos theta. Okay, now our major priority here now is to find the value of theta, and when we get the value of theta, to get the value of this expression here will be very easy. Okay, now how do we get the value of theta here? Okay, let's see what we're going to do. Remember that x plus 1 over s is equal to 3. So instead of writing this, we substitute it using 3. So is equal to 2 cos theta. Now dividing both sides by the coefficient of cos theta, and that is 2 here. So dividing both sides by 2 over 2, 2 gets cancelled out here. So we are left with cos theta is equal to 3 all over 2, and from here we get theta to be equal to the cos inverse of 3 all over 2. Okay, so solving for the value of x raised by 3 plus 1 over x raised by 3 will be very simple now. So we have x raised by 3 plus 1 over x raised by 3 to be equal to 2 cos. Right here n is equal to 3 because the power of x here is 3. So we have 3 times here theta. Remember we're using this above formula here. Here theta is equal to the cosine inverse of 3 all over 2. So we have the cosine inverse of 3 all over 2, then close bracket. One of the major things we need to know is that when calculating using the demoivre's theorem, we always look for a calculating device. Okay, when I input this in my calculator, 2 cos 3 cosine inverse of 3 all over 2 is giving me 18, and this is the right answer to the problem. Thank you for viewing, and please make sure you subscribe to my YouTube channel for more interesting videos.